Hello, everyone. I'm Dr. Michael Wu, and I'm the Chief AI Strategist at Pros. Welcome to the Modern Alchemy workshop. This is part 2 on artificial intelligence, and that is going to be the next evolution of the digital Darwinism. Before I begin, let's try to understand AI a little bit from a historical perspective. I think the best way to understand AI is to understand a little history of BI because AI actually evolved naturally from BI. So I'm just going to give you a little toy example to illustrate this very brief evolution of BI, of business intelligence. So what happens when you actually have lots of data? The first thing that people do is they start to summarize this data because there's no way for them to actually look at every single data point. So they start summarizing this data, compute some kind of statistics, right? For example, they could compute kind of the trend, right? Some resistance points, some kind of indicator, some kind of statistics, right? Local trend and all that stuff. So all these are what we call descriptive analytics. So descriptive analytic will basically help you summarize the data so you can understand what the data is actually doing without looking at every single data point. When you do this for a while, you start to see maybe some pattern, right? Then you can say, well, maybe I could do a little bit better than just summarizing these data, right? And maybe I could build a model, right? So this dotted line represents a model. Now, what happens when you have a model? What's the advantage of having a model? Having a model, one of the biggest advantages is that now you can extrapolate. You can actually extrapolate to regions where you don't have data yet. And in this case, since the x-axis here is time, right? Then we are extrapolating to future, right? So when we're actually extrapolating to future, we're actually doing a forecast, doing a prediction in the future, right? So then we move into what we call predictive analytics, right? So of course you continue to do your descriptive stuff, right? But what's the advantage of of having an eye into the future, being able to see the future? Um, well, if you could tell tomorrow whether tomorrow is going to rain or not, what would you do? You tell your friend or your family, bring an umbrella, right? Now you could tell people what to do. For example, in this case, if you want to make money, right? If I could have this forecast of the future of going up and down again like this, right? Then you could tell people that this may be a good time to buy, right? And this may be a good time to sell, right? So this is what we move into what we call prescriptive analytics, where we start to tell people what to do. We're basically prescribing an action for people to take in order to optimize some outcome. So in this case, if you buy and sell at this point, then you're gonna maximize your profit. So that's prescriptive analytics. So let's try to understand a little bit more about what descriptive, predictive, and prescriptive analytic is, right? So descriptive analytic is really, really easy to understand. Basically, it's there to summarize data. It's there to summarize data that already exists. So any kind of, I would say, charts or data visualization or report, right? It's basically a descriptive analytic. Now, predictive analytic is actually a little bit more, I would say, esoteric, right? A lot of people think of predictive analytic as forecast, right? Some kind of forecast. And that is true that I would say one of the most common use case of predictive analytic is for making forecasts, making estimate of the future, right? But really the more generalized way, a better way to look at predictive analytic is look at them as a process of inference or estimation, right? Basically, you're trying to estimate something, okay? So in predictive analytic, you basically will build a model and then you basically will feed it with some kind of data that you have, okay? And then it will actually give you some data that you don't have. You will actually make an estimate or make an inference on the data that you don't have, but you want to have. So the simplest example is forecasting, and for example, in a trend line. So in that perspective, basically, you are basically making usage of the data that you have is basically historical data. And the data that you don't have is basically future data. In fact, no one can actually have future data, right? So you can only estimate it. You can only infer it from historical data, right? So that's forecasting. But there's actually many other examples, right? For example, age estimation, right? So there's one time I actually walk into a Microsoft office where they have this camera actually filming me coming in, and they actually tag me as a male, right? And they actually give me an estimate of my age, right? So basically, the data that you have is basically a frame of image, right? A picture of people, right? And then you can actually your model could actually make an estimate of their gender and their age. So You could do demographic inference. For example, sentiment analysis is also a kind of predictive analytics, even though you're not really predicting anything, right? But in the more general perspective of predictive analytics, you're actually taking data that you have, right, which is some kind of text, some kind of article, some kind of tweet, some kind of blog, right? And then you feed it into this model, which is some kind of sentiment classifier, and then you're trying to output people's sentiment. What are people feeling? What is people's sentiment about some topic or some issue? So that is predictive analytics, right? You're basically trying to use data that you have to make an estimate or inference of data that you don't have. So lastly, let's try to understand what prescriptive analytics is. So prescriptive analytics, the simplest example of that is a GPS navigation system, right? Because in a GPS navigation system, what do? We basically tell the GPS where we want to go, and then the GPS would basically prescribe a sequence of action for us to get to our destination. So it's prescribing actions to help you accomplish something, to achieve your goal. So descriptive analytics is all about summarization of data, right? Predictive analytics is all about using data that you have to make an estimate of data that you don't have, right? But why is prescriptive analytics all about optimization, right? So to understand that, let's go back to the example of a GPS again, right? So why do you think that prescribe you this particular route to get from A to B? If you actually look at this map, there's actually millions of routes, right, that you could bring you from A to B, right? There's actually, probably infinite number of routes. You can actually go around the globe and come back on the other side, right? So, there's actually many routes to get from A to B. The reason that they prescribe you this particular route is because it optimized for something. So early GPS actually optimizes for distance. So it may be prescribing you this route because this is the route that minimizes distance. So today, GPS actually become a lot more sophisticated, right? So they may actually prescribe you a route that is actually minimize travel time, right? So travel time may actually then depend on traffic pattern, may depend on weather, the local weather, right? So if some places gets flooded, right, then it's going to be very slow, right? So it actually can take in many other data sources to help you prescribe a route that minimizes travel time, right? So that's the perspective that you should have, right? Prescriptive analytic, is prescribing you something, but the reason that it prescribe you a particular thing, a particular route, a particular action to take is because that action is being optimized against some kind of objective function, whether it is shortest distance, maximizing profit, or minimizing travel time, right? It's optimizing something underneath. So one other example that I want to talk about is search engine, right? Search engine is actually a prescriptive analytic. So what are they actually prescribing you? They're basically prescribing you a set of websites for you to look at. So if it's a prescriptive analytic, it's got to optimize for something. So what is search engine optimizing for? Search engine actually optimizes the relevance of the search results to your query. That's why they prescribe you those sets of search results. Another prescriptive analytic is a recommender system, right? Why do you think that Amazon or Netflix will recommend a particular product for you or a particular movie for you, right? It's because they're optimized for something. And what are they optimizing? So say like Netflix recommender, right? What are they optimizing? They basically are optimizing the similarity of the content to your preference. So if you like horror movie, then they may start recommending a lot of horror movie. If you like sci-fi movie, then they start recommending a lot of sci-fi movie. So it's basically optimizing the similarity of your preference to the content. So that's what they're optimizing. That's why they're able to prescribe you those things, right? So another example that's actually probably maybe relevant for the audience here is bid price generation. We all know that bid price actually is generated from optimization process. It's from optimizing revenue. But in this case, let's turn the question around. What are they actually prescribing? Basically, it's prescribing you to sell a ticket only above this bid price. Or another way to say it is just don't sell any ticket below this price. That's the action that's being prescribed by bid price generation, right? This process of optimizing revenue, right? Okay, so that now you understand descriptive, predictive, and prescriptive analytics. That now you understand the history of business intelligence or business analytics, right? So the question is, what's next? What actually comes next, right? What comes next is really artificial intelligence. And artificial intelligence is really just, think of it in the simplest term, it's really just the automation of decision plus the proper execution of subsequent actions. Now, actually, that's not quite AI yet, right? That's actually the beginning of it. That's actually the inception of AI. So just to illustrate this in picture, right? Going from data to decision to action, traditionally, that has always been a human's role. At the end of the day, regardless of what the data actually suggests, human always make the final decision. But if you have this process of going from data to decision to action, all happen automatically, then you really have the beginning. You have the inception of AI. So this, for example, this is actually already here. And we've seen this, say, in algorithmic trading, right? Instead of, you know, giving you the data, right, showing you how different stock perform, right, or even using predictive analytics to tell you the future trajectory of certain stock, right, or even prescriptive analytics to tell you exactly which one to buy, which one to sell. It just does it for you, right? You just tell me your risk tolerance. Another example is automated loan origination. Why do you need a human there checking off boxes and then decide to give someone's loan? If someone actually meet all the criteria, just give them the loan, right? Um, so let's go back to the example of in the geospatial domain of a GPS again, right? So the simplest example of a prescriptive analytic system is a GPS that we're all familiar with. So the GPS basically, you prescribe us a sequence of action to get to our destination, right? But why tell us how to get there? Why not just take us there? Why not just drive us there? So that you have a self-driving car. So essentially, this is another example. So basically, it's automating those decisions, right? So if actually just telling you, you still have to decide, right? Do I want, you're telling you to turn right here, go straight, right? Or go, so you have to decide, right? Do I really want to turn left here? Do I want to go straight here, right? So rather than actually, you having the last say in these decisions, right? This self-driving car is actually making those decisions for you, actually just executing those decisions and actually taking you to your destination, right? So that is what we call the inception of AI, right? So now, so obviously, the self-driving car is it's not quite legal yet, right? And the reason is because they're not like super smart, they're not super intelligent, right? Some people, there's still horrible accidents that could happen, and so the really question that is of interest is what makes AI intelligent? What makes it intelligent? So a lot of people, if you actually Google around and search for this a little bit yourself, do a little bit of research yourself, you will find this image that people will say that, oh, what makes AI intelligent is deep learning, and deep learning is a kind of machine learning, and machine learning is a kind of AI. I would say this is actually a very, very popular image. Okay, I'm guarantee you will find this. In fact, this image is actually on Wikipedia. If you actually search for deep learning, you actually find this image on Wikipedia. So is that really what makes AI intelligent, right? But is this image even correct, right? So this image is actually not quite correct, okay? It's not completely wrong, okay? But it's very misleading. The way to properly interpret this image is that deep learning is indeed a kind of machine learning, but machine learning is actually not a kind of AI. Machine learning is actually used in AI. Today, pretty much all the AI systems that I know of have machine learning as a component of it, okay, as a component of AI, right? So machine learning is really a part of AI, right? But it's not AI itself. So an example that would really make this vivid is that we know that, for example, V8 is actually a kind of engine, and the engine is actually a part of a car, right? Every single car actually uses an engine today, right? So engine is actually part of a car, right? It's actually not a kind of car, but if actually kind of don't have those boundary definition there, it's very easy to come to the misconclusion that an engine is actually a kind of car. And that's ridiculous. When you're actually saying that machine learning is a kind of AI, that's just as ridiculous as saying an engine is a kind of car, okay? Because engine is actually not a kind of car, right? Just like machine learning is actually not a kind of AI, right? Machine learning is actually used in every AI, just like engine is actually used in every car. So we should just throw this picture away, okay? Instead, we'll give you a better picture, a more accurate picture of what's going on. So this picture actually starts with big data. Now, big data is actually turned into a model. Now, if you actually attended the part 1 of this workshop, the Modern Alchemy workshop, part 1, where we talk about machine learning, you would know that the process of turning data into a model is basically machine learning, right? So data scientists use this machine learning to turn their big data into some kind of model, right? And there are actually lots and lots of machine learning algorithm out there. So machine learning here is both, I would say, a verb, right? As a verb, it's just what data scientists do, the process of turning data into a model. As a noun, it's just think of it as really just names of machine learning algorithm. If you actually look in this list, right, deep learning is in fact a kind of machine learning, right? But it could be something as simple as decision tree. Now, once you actually have a model, once you feed it with new data, you will get some kind of analytic results. And then some decision will have to be made about what to do with those results, right? And typically that result in some kind of action, and actions will have outcome, and outcome need to be fed back into your system in order for your system to work better, more optimally. So traditionally, I would say that, so in the process of turning data into a model, right, that's a data scientist does this, right? So what about this decision? Decision is also traditionally made by human, right? Regardless of what the analytic result actually suggests, right? We decide what to do at the end. What about actions? So actions, I would say that some of these actions today can already be automated by machine, right? And a lot of, I would say, actions in the digital world can already be automated by machine. But a lot of things in the physical world still need human to be executed, right? And the reason is because I would say that robotic didn't advance as quickly, right? And in the digital world, a lot of things can be automated by machine because all it takes is actually execute some code, right? To actually execute some kind of action in the digital world. Now, what about feedback? Right? Feedback traditionally is also collected by humans. Right? Human basically we survey to collect feedback, right? And that's a common mechanism of collecting feedback. But this is actually, I would say, very, very slow, right? Surveys are very, very slow. But in order for the system to actually work, this feedback need to happen at pretty much near real time. Depending on what application is, it needs to happen as fast as the decisions are being made. So for example, in the case of, say, a prescriptive analytic system of a GPS, because when you're driving, you need to make real-time decision, right? So that's when this feedback need to be happen at essentially at real time, right? The feedback for GPS is really that blue dot that shows you where you are, right? That's the feedback to the driver, to the person who's actually using the system. But think about how useful a GPS would be if that blue dot updates itself, say with like a couple minutes delay. That's 2 minutes delay, right? 2 minutes can be a lot of time, right? So the first thing we need to do to get to the point where we have AI is that we need to automate these feedback processes. These feedback need to be tracked in an automated fashion. So in the digital world, this can be done very easily because you just need to write some code to instrument that tracking of the feedback. In the physical world, this is actually start to be made, I would say, feasible with IoTs and sensors and all these other devices. And if this model here, if it's actually good enough, then even this decision process can be automated. So the question is, how do we know if this model is actually good enough? The model is good enough if actually is able to match a human expert's decision pretty much all the time, right? Nothing is actually 100% in statistics. So that's why there's a little bit of sliver yellow there. That just means that human can always override, right? Humans can always, if the human disagree with the machine's decision, then human can actually override. Right? But if the model is actually good enough to come up with a decision that matches a human's expert's decision pretty much all the time, right? Why do we need to have a human making the last call, right? Because all they will be doing is saying that yes, 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 I agree, I agree, I agree, I agree, pretty much all the time. And why waste the time to do that? Why not just let the machine automate that? So in this process of decision can also be automated if the model is good enough, right? Now, what about action? So as I said earlier, right? So action, I would say that until robotic becomes more advanced, we still need to execute a lot of the actions ourselves. But I would say today, a lot of actions in the digital world can already be automated by machine, right? So if you look at only the digital world, then this kind of feedback loop here pretty much have, I would say, no human involvement, except in the rare cases that human disagree with the machine. But most of the time, we should just let the machine just do its work. Now, there's actually couple of implication here, right? If these everything here have virtually no human interaction here. One implication is that, right, this loop can actually go very, very fast, right? The second implication is that because everything is actually, executed by machine, right? Everything can also be tracked and digitized and become data. And once they become data, you can actually feed those back into your big data, right? Once you feed it back into your big data, your data actually change, right? Your data actually contains more data now, right? So that, yeah, if I go through this machine learning process again, right? Basically, now you actually have a way to update your model and give you a better model, right? So this model now will be a better model because it actually has the previous data plus this new data that come in because a decision is being made and some outcome is being tracked and feedback to your big data store, right? So basically, you could basically do this model updating in a completely automated fashion, but typically that's not a very, very good idea. There's actually lots of um, examples of this could go wrong. So we want to have some data scientists or to oversee this learning process to make sure that the machine actually learned the right thing. So so sometimes machine can actually learn the wrong thing. Okay, you may learn something that may be illegal, maybe learn something that may be unethical, right? So these are things that data scientists needs to watch out for to make sure that the model is actually learning properly the things that they should learn. Basically, once you have this, right, the model basically you can get updated pretty much every time you use the system. So this model actually gets better and better every single time you use the system, right? And it actually eventually becomes a really, really good model of the process of of going from decision to action to outcome. Basically, this is the learning loop. The learning loop is actually what makes AI smart, okay? Because every time you use the system, you generate new data, and these data gets actually, go through the machine learning process and you update your model. So the model becomes better than the previous model that you have, right? So if you do this every single time, right, the model gets better and better, and better, right? Eventually it becomes maybe as good as a human, right? So this is the learning loop, and it's actually what makes AI smart. So now we are actually ready to define what AI is. Okay, so it's actually a pretty dangerous to define artificial intelligence because this definition changes over time. The definitions of AI actually evolve. Some people actually says that AI is whatever machine can do now that they couldn't actually do before, right? And there's some truth to that because when optical character recognition came out, a lot of people think that this machine is amazing. It's able to read prints. Not only can it read prints, it can actually read handwriting. Not only can it read like my handwriting, but yours and his and everybody's handwriting. So it seems like this machine has some AI. So OCR used to be thought of as an AI capability, but today your phone could actually do optical character recognition, and that's no longer considered as an AI anymore, right? So just take this definition of AI with a little bit of grain of salt. But I would say at this stage of the evolution of human history, right now at this time, right, the way I like to look at AI is that it's a machine mimicry of certain aspects of human behavior with two important characteristics, right? So it's a machine mimicry of human with two characteristics. One is automation. It's the ability to automate decision and subsequent actions that human do. And the second one is this learning we just talked about, right? It's the ability to learn. And what that means is that it's the ability to improve its performance with usage. Every time you use it, it actually gets better at what it's doing. So if you have something, a machine that try to mimic human that can automate and can learn, right, then you really have an AI. If you just have the automation, then it's actually no different than just factory automation. It's not a smart machine, right? It's not a machine that can learn and adapt to different situations. Okay, and I like to just reiterate that machine learning is actually not the same as AI. Just because you built something using deep learning, using machine learning, it doesn't mean you have an AI. Okay, so I just want to illustrate the power of this learning loop with an example that a lot of you probably have heard in the news already, right? So there's this program called AlphaGo. They play the game of Go, right? And it's able to beat this world champion, grandmaster in the game of Go. So how do you think AlphaGo is able to do this? Right? AlphaGo, it's actually a program written by engineers, right? And they're trained with realistic, I would say, gameplay data from professional Go players, right? But these Go player, none of them are actually as good as this Lee Sedol, right? This world champion, right? Because he's the best guy in the world, right? By a far margin. So how do you think AlphaGo is able to beat this world champion? So think about this for a minute. So this speed actually comes into play here is because if you actually play a game of Go against a human, right? Typically take you, I don't know, a few hours to play a game. So if you actually look at the human experience, how many game can a grandmaster play in his entire lifetime, right? I would say like 100,000 game or something like that, maybe more or less, right? But so AlphaGo is actually trained with realistic gameplay, right, from these experts, right, from professional players. Now, once you train the AlphaGo to be good enough to play a real human, then what happens? You can actually let AlphaGo to play against AlphaGo itself and conduct what we call this self-play, right? They play against itself. Then this speed becomes really, really fast, right? They could actually play like, thousands of games in matter of like, I don't know, hours, and you could play like in a matter of weeks or months you could play like millions of games, right? If that's not enough, just throw more CPU at it, right? Then you could so this is actually really, really crucial. It's because this learning loop can actually go very, very fast. Every time when you AlphaGo play against itself, right? Some versions of it have win, some versions of it will lose, right? And from that, each one of them actually update their model and become better and a stronger opponent of each other, right? So each one of them gets better and better, right? So basically, AlphaGo can play like millions of game in a matter of a few weeks or a few months. So basically, AlphaGo can, essentially make all the mistake that a human expert like this world champion make all the mistake he could ever make in his entire lifetime and learn from those mistakes and never make those mistakes again, right? And this is how AlphaGo is able to beat this world champion. Okay, pretty amazing. Okay, so and from working with a lot of companies around this adoption of AI into their business, so a lot of companies would say that, well, what can AI do for me as a business? As a business, what can they do? I know AI has been around, in my phone, in my smart home devices, and all this stuff. But what can it actually do for my business, right? What can it do? So I think that's really the wrong question to ask. And the reason is because AI is really this general learning algorithm, right? This machine learning is actually pretty general, right? It can basically do everything that we can do, provided that we can digitize the things that we do, right? So it can do everything that we can do that we can fully digitize. The key word here is fully digitize, right? So because if we are able to fully digitize some process, we would have the data that's necessary to train the AI to mimic what we do in those processes, right? So the key thing is that we have to be able to fully digitize these processes. If there's something that we do, say it has like 10 steps, and we're only able to digitize 9 of the steps, and we can certainly automate those 9 steps by training an AI to do those 9, but don't expect the AI to be able to fill in the last step for you. It can't. Okay, there's no data to train the AI to do that yet. It doesn't know how to mimic us. So, but if you can digitize the last process, then yeah, then the AI could, very well be able to fully automate this process for us, right? All 10 steps, right? So really the right question, the important question to ask for business is really what can you digitize, right? Because anything that you can digitize, you will have the data, and then you will be able to have the data to train the AI to mimic what you do, right? So really the question that the company should ask is what can we digitize? Now you know that all AI need is really data to train it. And there's actually lots and lots of, I would say, data out there. We are actually living in a world of big data today. Okay, so we have actually are overwhelmed with data. So because of that, there's also, I would say, lots and lots of AI application, because all those data can be actually used to train some kind of AI. So there's actually thousands of, I would say, tens of thousands, hundreds of thousands of applications of AI out there. But instead of going through every one of those applications, I won't have enough time to do that. But what I think is useful is to actually look at 4 big major categories of applications of AI. Okay, and these are very, very important in the recent days, and I think they will be in the years to come. But I think this could change over a longer period of time. But I think this right now is actually a good way to understand the landscape of AI with these 4 major categories of application. So the first is perceptual AI. So perceptual AI is sometimes also called cognitive AI or cognitive computing, because they are basically trying to mimic the higher cognitive function of a human, such as speech, language, vision, and so on. Okay. So now these perceptual AIs, their main function is in human-computer interaction, right? And there's no surprise to this use case is because if you have a machine that could see the world as we do, and they could actually talk back to us using our language and can understand our language, we don't have to write code to tell them what to do, right? Then of course we interact with the machine a lot better, right? So there are many examples of this. For example, Microsoft's Cortana. If you use Amazon, you have Alexa. If you use iPhone, you have Siri, right? Even pros have our Monet digital assistant, right? So basically, this class of AI consists of primarily, I would say, some kind of chatbot or digital assistant or some kind of computer vision system. Okay. So that's perceptual AI. Now, the second class is actually something that's very, very common, and I think everybody understands it. This is internet AI, because internet generates so much data, from us surfing the internet. So that just means that we probably surf the internet too much, right? So we generate lots of data on the internet, right? So if you feed all this data into AI, a learning algorithm, and train the AI from that, right? Basically, you get a recommender system, and the recommender system can actually recommend product or movies or content for you, right? So early pioneer, this include like Amazon's. They have a very famous recommender system, that goes under the very long name of people who bought this also bought that. So that's a very classic recommender system. And Netflix and Spotify soon after have had their versions of the recommender system as well. So basically the learning loop is that if they recommend you something, right, and then whether you actually go and purchase it or whether you actually go and watch it and listen to those music, right? If you actually do that, then they basically would know that to update the model that to recommend you more of those similar type of content that they recommended to you, right? If you didn't, right, if you actually say, no, this is actually irrelevant, I don't want to, or you didn't listen to it, right, then it's going to actually refine the model and maybe recommend less of those content for you because they know that you didn't like it. So that's internet AI, right? And the biggest application of internet AI is in, I would say, personalization. So internet AI is sometimes also called personalization AI. So the next class is autonomous AI. So autonomous AI is the AI behind the self-driving car. And the biggest application of autonomous AI today is the self-driving car, okay? But that actually won't be the case forever. And I think that soon after, autonomous AI will be used to drive other machinery such as robotics, right? So in fact, today, I would say Amazon's fulfillment center, their warehouse, actually have lots of robots in there that's actually driven by this type of autonomous AI. So they have these shuttle bots that actually shuttle the inventory around the warehouse. I think in the future they will be driving other robotics, such as robotic barista, robotic waitress or a waiter. Actually, San Francisco actually already have a robotic barista. So in the future, they may even fly autonomous drones as well. Now, the next class is business AI. So the biggest application of business AI is business decision automation. They're very diverse because there are so many different, I would say, industry and so many business function and specialization out there. And they're also less well known because typically these AI are used by very specialized people with special domain knowledge. So some applications of this, it would be, for example, fraud detection, algorithmic trading, right? Machine-aided medical diagnosis. So Watson actually early on did a lot of these machine-aided medical diagnosis. Today, very, very importantly, due to the coronavirus, is in in drug discovery, right? Machine-aided drug design, machine-aided drug discovery, right? So these are very, very diverse, very, very different domain. And in fact, Pros is also a business AI. Pros actually automate the decisions of pricing for a lot of our customers. So that's business AI, right? At the end of the day, I think a lot of people still say, well, what can these four type of AI do for my business, right? So, and I would say that, there's many, many things you can actually do for your business, but I like to simplify it down to three very, very important outcomes today. The first thing is that these AI can help you improve your customer experience. And the second one is that actually it can actually help you increase your efficiency. And the third one is that it can actually help you grow your revenue. So just like there's actually thousands of tens of thousands of different AI applications out there, I boil it down to four major categories. Likewise, there's actually, I would say, thousands and tens of thousands, hundreds of thousands of benefits that you can actually get from AI, from all the different kinds of AI out there, right? But I boil it down to three main categorization of benefits that AI could provide to your business. So now choosing the right AI technology for you really comes down to understanding what are you actually trying to accomplish. What kind of business impact do you want to have, right? If your goal is to try to, for example, improve your customer experience, which type of AI would you choose to accomplish this? If your goal is to deepen engagement, to boost conversion and gain loyalty, which type of AI would you choose to accomplish this? Basically, is the first two. Is this perceptual AI, sometimes called cognitive AI, right? Because, obviously, if people can actually interact with machines better, right? Obviously, they will have better customer. If you actually use this in a customer-facing function, right, then you can actually help you improve customer experience, right? And likewise, if machine can understand your preference, understand what you like and what you don't like, as in internet AI, in personalization AI, right, then they can also help you improve your customer experience too, right? Now, the second main, I would say, benefit that could be come out of the application of AI is increased efficiency, right? If your goal is to kind of save costs, to save money, right, or to raise productivity or to increase throughput, right, which type of AI would you use? In this case, I would say that one of the main use case of perceptual AI, when it's not used externally for customer, when it's actually used internally for employees, is that it actually increases productivity. So it can actually increase efficiency by raising the productivity of your employees. So the second way is that you can actually use autonomous AI. You can actually replace an employee with robots, right? And obviously, robots don't need to rest or sleep, right? So they can be much, much more efficient than the human, even though they have other drawbacks. So they can actually increase the efficiency of your business that way. And the third one that I want to talk about is business AI. Because this decision AI automates business decision, right? So they typically can directly help you automate decisions, so you can actually make this decision faster, right? So very often, I would say business don't go very fast. It's not because certain process are being slow or anything. It's indecision, right? It's the fact that they can't come to a decision, and then therefore they slow down the business. So a lot of business AI is actually designed to actually make these business decision automated and much, much more efficient, so your business runs faster. So that is the second main benefit that come out of AI. So now, if your goal is to grow revenue, right, to expand your top line, to grow margin or drive profitability, which type of AI would you pick? Probably there's only one that you could do, is to make better business decision, right? So these are the ones that can help you drive the top line. So now we should not interpret this figure as that perceptual AI or internet AI cannot drive growth and revenue. Okay, in fact, they can. In fact, every one of these AI can drive every one of these outcomes. For example, you could say that, perceptual AI can improve your customer experience, and therefore your customer actually like to do business with you more and buy from you more, and therefore grow your revenue that way, right? So it can, right? Every one of these AI can actually drive every one of these outcome, but the most direct impact can be driven by each one of these AI is illustrated by the biggest dot here in this picture. Now let's take a look at where pros come in when it comes to these four categories of AI. As I mentioned earlier, we have Monet, which is actually a digital assistant and that's a perceptual AI, and it can certainly improve customer experience and also increase efficiency, right? If it's used in a customer-facing or for employee-facing function. And for internet AI, we actually have offer optimization, and this is actually being used by one of our airline customers already. Where pros is actually our core strength is in this business decision AI that help people make better decisions about pricing, about opportunity, which opportunity to pursue. And certainly when you actually make this, when you're able to make these decisions faster, right, your business also operates much, much more efficiently. So the increased efficiency category, I just want to say that this is actually a pretty crowded industry, right? Lots and lots of AI are out there. They were created to actually optimize, to make certain inefficient business processes much, much more efficient. Okay, so that's actually very, very crowded space. That's why there's so much there, you know. So let's dive a little bit deeper into what pros actually do, just to give you a little bit of context into what these business AI can help you with. So the way I like to look at it is pros is a company that help you monetize more effectively and more efficiently, right? Essentially, that's what pros do. And we provide two sets of tools that help you monetize more efficiently and more effectively. One is pricing tool, and the other one is sales tool. And obviously, you know, pricing tool is important to help you monetize because pricing has the most dramatic impact on monetization. And we can demonstrate that 1% change in price can actually lead up to 11% of margin improvement, right? So in fact, you know, 1% change in price can actually drive more impact, have bigger impact on monetization than 1% change in pretty much anything else in your business operation. Okay, so and pros actually have a lot of, I would say, solution in that in this pricing tool category, right? In our revenue management for the airlines, we have our guidance for our B2B customers. We have real-time dynamic pricing. We have, you know, e-commerce guidance, right? So there's a whole lot of, I would say, pricing tool that we provide for our customers. So the next set of tool that pros provide is what we call this sales efficacy tool. So these are tools that make the sales process more efficient and more effective. And obviously, you know, if price has the most dramatic impact on monetization, sales probably has the next most direct impact on monetization, because you know everybody knows that if we have a more effective and more efficient sales team, right, then we certainly can drive higher revenue and higher margin. So this is the sales is probably the next most direct impact on monetization, right? And pros also has solutions there, right? Our opportunity detection that I mentioned earlier, right, essentially makes your sales more effective. It tells your sales to focus on these opportunity and not these or these, because these ones are much more likely to turn into real deals. The differentiation that we offer is that not only are we able to tell the salesperson, you know, what to sell to whom, when, right? We can also tell them how to price it, right? So together with our pricing solution, this is actually a very, very powerful solution. And then we also have CPQ. So CPQ actually can make the sales process much, much more efficient. So they could actually go from configure to price to quote very, very quickly. So this typically usually is a very, very slow process, especially in B2B. It's lots of negotiation, lots of different parties involved, but it can be streamlined and make much, much more efficient. So that's actually how pros actually are using AI solution to help our customers. So with that, you know, I just wanted to say that, you know, like the ability to learn is actually crucial, right? That's why I call this is the next evolution of the digital Darwinism. Darwin basically says that it's not the strongest species that survive. It's not even the most intelligent that actually survive. It's the one that actually is most able to adapt to changes. Okay, and the ability to learn give you the ability to adapt to changes. If you don't learn, then you cannot adapt to different environment. Then basically you will be obsolete. So with that, thank you for your attention.